All right, welcome back to section 6.4, and we got a little bit more complicated example. We found a test statistic a couple of times, and now we have an entire question here. It says you wish to test the following claim at a significance level of alpha equals, so I'm going to get my alpha down here, 5 thousandths. So we got that. Sorry, I got some windows that popped up over here. And we have the null hypothesis that these things are equal, and the alternate hypothesis is that they are different. So we have a two-tailed test. Some important information to glean. I know this is kind of zoomed out a little bit over here, and I can maybe zoom in, but I got to get this information. So we need to find our sample standard deviation and the mean of our sample and our counts. So just grab sample 1, and I'm going to place it here, I suppose. And again, like to paste special. And this is sample 1. And then sample 2, we'll kind of get it over here. Copy and paste. Again, going all special here. And we've got that. Now we're looking for the test statistic, the p-value, compare the p-value, and then make a decision. So I think I'm going to go ahead and make this a bit larger so we have some more room to work, and maybe that will be helpful, maybe it won't be. But I kind of need to go through and find n sub 1 and x sub 1 and s sub 1, as well as n sub 2, x sub 2, and s sub 2. Oops, forgot the extra s. Okay. So, if I grab this sample here, let's get the whole thing. It says we've got 62, and we've got 4 by something, so we can't get 62. I really did count these. We've got 62 here, and then over here, we've got 58. So just counting up our samples using the count on the bottom here, nothing too crazy. You can also use the count feature if you like. Feel like it's not quite worth it. Now, I did go through here and verify that if I grab more data points, it doesn't count against me here. So when I'm looking for x bar sub 1, I can go ahead and grab that whole rectangle, and it will be the same as if I just grabbed the data that I wanted. Similarly, the standard deviation of the sample, you can do this. You can also just hold down Control and grab a couple more, and it compares those. Again, if I did the standard deviation of the sample and just grab the whole rectangle, it doesn't count those against me. So feel free to do that either way. Similarly, we need to get the average over here. So that data we were given on the previous questions, we really have to just gather it together here. And I'm going to not necessarily bother trimming the areas down, and I'm going to grab these. And because I double clicked and rearranged when we have one sort of wide column here, and that's okay. We'll just roll with the punches here. So now we're sort of back to where we were on those previous questions where we found the standard error and the test statistic. So I'm going to find my fraction for the first group. I feel like I did that last time. And again, it's our sample standard deviation squared over our sample size. And again, that's this right here, s sub 1 squared over n sub 1. And I'm going to do the same thing for fraction 2 over here. The standard deviation of that sample squared, whoops, over the sample size. So, got my fancy fraction. I can use this to find my standard error. And the standard error is the square root of the sums of these. That's this right here. I have the first sum and the second sum. So now for our test statistic, we can figure out that next, kind of keeping the same order as what we have had. We will take, and we need a grouping symbol on the top, x bar sub 1 minus x bar sub 2, and divide by the standard error. So now, we have a negative test statistic, so that means we're going to have a distribution that looks something like this. Here's 0, here's negative 0.4, 2, and some stuff. And our two-tailed area is going to be this one, and we have one mirrored over here to figure out our p-value, just to understand what's happening with that picture. Okay, so we've done this, we've done this. Now we need to work towards that degrees of freedom. And for the degrees of freedom, there's a numerator and a denominator. I like to break it into those pieces here. So the numerator is, and you'll notice I have my fancy fractions plus my other fancy fraction, and that quantity is squared. So I'll take my fancy fraction and my other fancy fraction, and I'll square that quantity. So this is the numerator, that's the top. And then the denominator, we have 1 over n sub 1 minus 1. So 1 over n sub 1 minus 1. You can think of that kind of like our old school degrees of freedom, but we're actually calculating the degrees of freedom here, so you might not want to. And then we multiply by our fancy fraction, and notice it's squared. And then now we have plus 1 over n sub 2 minus 1. So I had to start a grouping symbol there, and it is multiplied by our fancy fraction, and for the second one, and that is squared. Yeah, we'll accept the correction. Let's see, this times this squared plus 1 over this squared. Not sure what I forgot to close out, but that looks pretty good. I'll copy and paste it over here. And then this means our degrees of freedom is the numerator divided by the denominator. Now we've had a lot of whole number degrees of freedom. This one doesn't really shake out that way. And so now when I go to find my p-value, I've got to do 2 times a t-distribution, and I can use my test statistic, comma, my degrees of freedom, and true, and I'm getting a value out here like so. Quite a bit to it here. Again, find this fancy fraction here that's in here, also here and here. Running through, we had to take the data sets and use those to find this. I pasted special. We drew a picture of our p-value and what it's going to look like. And then this sort of matches up here. So I'm going to go back to try to answer the question here. See if it'll let me snap it all back together. Our test statistic is there, negative 0.428, followed by a 7. That's going to go to 429. And our p-value is a little further over here. 0.6689. Okay, now we compare that to alpha. This is definitely greater than alpha, which means we failed to reject the null hypothesis. And after all that work, we cross our fingers and hope it shook out okay. And it did. So again, going through the whole process there, these take a good bit of time, and that's why the section is shortened up a little bit. Pay close attention. It's really good to show your work in a clear way. I like this way. Anyway, good luck. I'll probably work another example, but you kind of know enough to get started here if you want to.